Hi everyone, I am Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. Today in this lecture, we are going to discuss about storage classes in C language. So coming to the overview, we are going to discuss about the storage classes and also about the types of the storage classes with examples. So coming to the storage classes. Storage class of a variable defines about the scope and lifetime. So scope and lifetime of a variable declared within the C program. So coming to the scope and lifetime, scope of a variable determining over what region of the program a variable is actually for use. So when we are using that particular variable, we'll tell about the scope. And coming to the lifetime of a variable is period throughout which the variable exists in the memory. So over what period that variable will exist in the memory. Scope will tell about the usage of the variable, and next lifetime will tell about the how much period the variable will exist in the memory. So coming to this syntax, this is the storage specifier and this is the data type and this is the variable name. So as we know, this is the syntax for declaration of a variable. So in front of the syntax, we are specifying some storage specifiers. The storage specifiers are nothing but the 4 types of storage classes we have. So that 4 types of storage classes, the variable belongs to which storage class, that we are going to mention in this storage specifier. So next is the types of the storage class. So in the C programming language, there are 4 storage classes and they are as follows. So the first one is automatic storage class, next is register storage class, static storage class, and finally we have some external storage class. And we are going to discuss about all the storage classes in detail. So next is the automatic storage class. So the default storage class of all local variables, the variables which are declared inside the block or a functions, is nothing but an auto storage class. So all the variables will come under the local variables, so that belongs to the automatic storage class. So till now, whatever the programs we have seen and whatever the variables that we have declared, so all those variables will come under, by default, all those variables will come under automatic storage class. So coming for an example, so the keyword here, it is an auto, and the next is data type is int, and the variable name that we have taken it as an x. So this is nothing but an example how we are declaring an automatic storage class variable. So coming to one example, so by seeing an example program, we'll get a clear-cut detail of this storage classes. So here we have declared a function, the void is my return data type and function 1 is the name of the function, and here the parameters is empty. That is the reason why we are not passing any parameters inside that function. And the next is the main function. See here, the auto keyword. For automatic storage class, we are using the keyword as an auto. So in front of this variable declaration, we have given an auto keyword. So which means the A variable belongs to this automatic storage class. So by default, if you specify auto or if you doesn't specify auto, those variables will come under the automatic storage class. And next we have declared a variable and also we have given value to that variable. A is equals to 20, and then next we have called that function. So what happens whenever we call the function, it will come to the function definition. So here the function definition, and here also we have given an auto keyword, and this is the A is equals to 10. So this is sort of different blocks. This is for main block and this is the user defined block. So here we can use the variables of the same name. So the memory allocated for those variables will be of different. For A, in the main function got memory allocated consider in the 100 location, and in the user defined A, the memory allocation got at some 200 location consider. So here we have given inside the main function, this is a variable, and inside the function, this is the memory allocated to the A variables. And inside the main function, we have given A value as 20, and inside the function 1, we have given the value as a 10. So this 20 will stored in the 100 the location and 10 will be stored in the 200 the memory location. So we are using function concept, so the different memory allocation will get for these 2 variables. And next we are calling the function. So it directly will come to the function definition, and here also we have declared a is equals to 10, and by using this printf statement we are printing that a value. So the a value is equals to 10, so the 10 will be printed in the output screen. So this is the a is equals to 10. And again, after the completion of all these statements inside the user defined function, it will return back to the main function, and it will execute the leftover statement. So the leftover statement is we are printing that a. So here the a value is equals to 20. So a is equals to 20 will get printed by using this printf statement. So the scope is, I think you understood the scope and lifetime. The scope is nothing but availability of usage of the variable. So the a variable we can use only in this particular block. So the a variable inside the main function we can use only in this particular block, and this particular a variable we can use only in this particular block. So this a variable is available only in this user defined block, and the a is equals to 20, that variable is available only inside the main block. So the a equals to 20 we cannot use inside in the user defined function, and a is equals to 10 we cannot use inside the main function. So the availability of usage of the variable, that is nothing but the scope of a variable is only in this block for this main, and a for this in this block for this user defined function. And the next, coming to the lifetime. So lifetime is nothing but over what period the memory will get existed. So whenever we enter into this user defined function, after completion of this statements what we have given in the user defined function, it will return back to the main function. So whatever the memory allocated for this a is equals to 10 will get freed. So the memory allocation, the period where what the memory is getting existed for this user defined function is till the completion of the statements execution of this block. So coming to the scope and lifetime of the automatic storage class, the automatic storage class scope is within the block, and the lifetime of the automatic storage class is also within the block. Whenever the block exists, the memory also will get freed for that particular variables. Register storage class. So when a variable is declared using register storage class as its storage class, it is stored in the CPU register instead of RAM. So for example, register is a keyword and it is a data type at X. So this X belongs to this register storage class. So as we discussed, this storage class is completely about the variables. So we're discussing the storage class completely about the variables. So this register storage class, the scope and lifetime of this register storage class is also same as the automatic storage class within the block. If we come out of that block, we cannot use that variable, and if we come out of that block, that the variable no longer will exist in the memory. So here we are going to see the example program of exponent, that is nothing but the power. So here we are taking the exponent as a function name, int is my return data type, and int a and b. So these are nothing but the a and two inputs that we are passing to this function. Exponent means, as we know, that is nothing but 2 to the power of 5. So a here is nothing but a is 2 and b is nothing but the 5. So these are the two inputs that we are giving to that exponent function. And the next, inside the main function, we have given a is equals to 3 and b is equals to 5. And one more variable that we have declared, that is result variable, to store the output. And next we are calling the function exponent function with two values as an input, a and b as an input. So whenever we call this function, the function will return to the function definition. So the a value will be copied to this a and b value will be copied to this b. So here we have some two blocks, that is main function and the user defined function. So the memory will get allocated to this main block and user defined block will be different. So for example, when we declare this variables for inside the main block, a is equals to 3, consider it is stored in some 100 location, and b is equals to some 5, consider it is the 5 value is stored in some 200 memory location. And then next, here also we have given that a and b values we are declaring inside the user defined function. So in this exponent function also, for a memory will get allocated and b memory will get allocated. Consider a got memory allocated at 300 location and b got memory allocated at 400 location. So 3 value will be stored here and 5 value will be stored here, because the a value in this main function will be copied to this a, and B value in this main function will be copied to this B. So here the memory allocation of these two A and B variables will be of a different. So as we seen in the call by value and call by references. So here the variable names are same, even though variables and names are same, the memory allocated for those variables will be a different. So here, and next we have here register storage class, and here 6 int power is equals to 1. So this power is equals to 1. So we have already discussed, it is when you are using this register storage class, it is stored in the CPU instead of this RAM. So in CPU we have some 16 registers. So in that 16 registers, the value of this power equals to 1 will be stored. So in this particular register, one register we are using, and in that one register, the value of this power is equals to 1 is stored. And here we are finding the exponent, that is nothing but the power a to the power of b. So that is the reason why we are using the for loop, and here we are running the for loop for b number of times, because this a we need to multiply for b number of times. So that is the reason why we are taking I is equals to 0 and I less than or equals to I is equals to 1 and I less than or equals to b. So in the first iteration, I is equals to 1 and 1 less than or equals to here b is 5. And the condition is true. So if the condition is true, so power is equals to power into a. Here the power value initially we are taking it as 1. So 1 into a. Here a value is nothing but 3. So 1 into 3 is nothing but the 3. And we have given here I plus there's nothing but we are incrementing the I value. So I will be equals to 2 and 2 less than or equals to 5. It's again 2. So here power is equals to power into a. Here the previous value of power is 3. So 3 into 3, that is equals to 6. And the next I is equals to 3 and 3 less than or equals to 5. Yes, it's 2. 3 into 3 is 9. And the next power is equals to, condition is again to inside the for loop. So again power is equals to power into a. That is power we have got is equals to 9 into 3. So that is equals to 27. And the next, if I is equals to 4 and 4 less than or equals to 5, the power is equals to power into 3. That is 27 into 3 is nothing but 81. Then next, in the next iteration, I will be equals to 5 and 5 less than or equals to 5. Yes, it is true. So if it is true, power is equals to 81 into 3, that is 243. And the next I will get incremented, I will be equals to 6 less than or equals to 5, the condition will be false. And from the for loop, we are coming out of this for loop, and in the next statement, we have return power. So the power value, whatever we have, that is 243, that value will be returned back to the main function. And here by using printf statement, this percentile d, this place will get the a value, and here the a value is 3. So 3 is a power, 3 power b. B is nothing but the 5. 3 power 5 is equals to result. The result value is equals to 243. So whatever the value we have got, that value will be assigned to the result value, and the result value is 243. So 3 power 5 is equals to 243. So here the main important point that we need to remind in this register storage classes, we have some 16 registers in the CPU, and that 16 registers the variable will get stored. So what is the process is happening by in the background is whatever the values that are stored in the RAM. So from that the value is fetched into the CPU, and in the CPU operations has been done, and again it will return back to the RAM. The value will be stored, return back to the RAM. But if we declare the variables of the register storage type, so no need to fetch the data from the RAM. So we have that variable value inside the CPU itself. So with the process will be very fast and easily accessible. The process is very fast when you are using this register storage class, and the values also we can access it very easily. And the next storage class is the static storage class. So the static storage class is used to create variables that hold values beyond its scope until the end of the program. So the static variable allows to initialize only once and can be modified any number of times inside the program. So as we already discussed in the Fibonacci series, the static value which retains its previous value. Whenever you call the function value will, whatever the value has been changed, that value will be used in the next function call. So here, for example, the static is the keyword for that we are using for static storage class, and data type and x is equals to 10. So here just a small example that we are taking, that is nothing but incrementing those static variables and automatic variables. And this is the main function, and this is the function declaration. Void is my return data type and increment is my function name. And next, inside the main function we are declaring this I, and we have taken a for loop, which means we are calling this function for 3 times. We're calling this increment function for 3 times. So whenever we call this function, it will come to the function definition. And here we have given automatic storage class, that is for a variable. We have declared that a variable using automatic storage class, and we have declared this s variable by using this static storage class. The values of that a variable and s variable, AVAR and SVAR is equals to 1. So we are calling this, if I is equals to 0 and 0 less than 3, as the condition is true. So then we are calling this increment function, it will come over here. And here we have declared a variable. So the value of a variable is 1 and s variable is equals to 1. And this is of automatic storage class, and this is of the static storage class. And by using this increment operator, we are incrementing those two variables. So here the variable will get 2 and s variable will be is equals to also the 2. And by using this printf statement, we are printing a variable value and s variable value. Say in the first iteration, a is equals to 2 and s variable is equals to 2. And after completion of the user defined statements execution, it will return back to the main function which it called. So again, I is equals to I increment. Now I will be equals to 1 and 1 less than 3. Yes, and the condition is true. If the condition is true, by using this increment function, it will come to the user defined function which is this called. And again, automatic variable and static variable. So here the values of a is equals to 1 and static variable value is equals to 2, which means the value in automatic variable after completion of this after completion of the execution of these instructions, so the memory, which means the memory allocated to that, will get freed. So as we discussed in the automatic storage class, the lifetime of that variable, which means the memory access to that variable, is within the block. After when we once step out from this block, the memory will get erased for that automatic variable block. But coming to this static storage class, the memory will get accessed until the program ends. So here again for this a variable, memory will get allocated and one value will be stored. But coming to this s variable, the value of this s variable will be 2. So consider here some 100 location and consider it is some 200 location. The memory existence of this s variable will be existed through in this particular thing throughout the program ends. But coming to the automatic storage class, the memory will get terminated or the memory will get freed whenever we once exist from this user defined a function. So here again we are taking, so consider it as 1 and it retains its previous value because the variable exists in the memory throughout the program ends. So here we are incrementing a value and again we are incrementing the s variable. So one variable will be 2 and here the s variable will be is equals to 3. And by using this printf statement, we are printing a variable and s variable value. So a variable value is equals to 2 and s variable value is equals to 3. So the program again returning to the execution control is again returning to the main function. Here the automatic variable availability and also the memory existence will be freed. So again here the I variable will get incremented. Now I is equals to 2 and 2 less than 3. Again condition is true. So again we are calling this function. So it will return to the function definition. So again automatic variable, again for automatic variable memory will get allocated. Consider it is some 300 and the value that we have given is 1. So one value will be stored in automatic variable, and in this S variable, the S variable value will be retained. Its previous value will be retained. So the S variable value will be is equals to 3. So and here we are incrementing those two variables. So A variable will get 2, and this S variable value will be is equals to 4. And next we are printing this A variable and S variable. A variable is equals to 2 and S variable is equals to 4. So whenever the execution completes in the user defined function, the memory allocated for this automatic storage class will get freed, and also we cannot use that variable anymore. So when we are exiting from that user defined function, again here I is equals to 3 and 3 less than 3, the condition is false inside this for loop and the program terminates. So when you check the output of this, the A variable of the value of this automatic variable is always same. But coming to the static storage class variable, it retains its previous value, whatever the previous value it has. So that value is used in the next function call. So that is the reason why whenever we are incrementing this S variable, the value is getting incremented. So the last storage class is the external storage class. So in the external storage class is used to give a reference of a global variable that is visible to all the program files. So whenever the multiple files in a program we are using and we need to use a particular function or a variable in a file apart from which it is declared, then we can use the extern keyword. So for example, so here the keyword that we are using is extern, and the data type is int and the variable is x. So extern variables are declared and defined at the beginning of a source file. So we have already told that it is a reference of a global variable. So that is the reason why we need to declare that variables globally. And memory is allocated for the external variable when the program begins the execution and remains allocated until the program terminates. So when we are using some multiple files, so that multiple C files, and in that multiple C files, you want to use that particular variable in all the files. So at that time, we are using this external storage classes. So for an example, so here in file1.c, this is one C file and this is the another C file. So two C files we are taking, and here we have declared int x globally, and the x value we have declared here. So the same x value we are using inside the file 2. So you can observe here in the file 2 we did not initialize any x values, but by using this printf statement we are printing that x value, which means whatever the x value we have used in that file 1, that value we are taking in the file 2 by using this extern keyword. So, and this is a header file and this is a user defined header file. For suppose if you want to use this, whatever the function declarations we have, function definition we have written in the file 2, that function definition we can import in this file1.c by using this user defined header file. And here we have given x is equals to 10, and by using this printf statement we are printing that x value. So x in the file 1, see x in the file 1 is equals to 10, and then next we are calling this print function. So whenever we call this function, it will come to the file 2, and here by using this extern we are getting the x value that we have given in the file 1. And then next in this print we have given x is equals to file 2. So x in the file 2 is equals to %d. So no x value we have declared in this file 2. So that x value we are getting from the file 1. So x in the file 2 is equals to 10. So we'll see this practically. This external storage class. See this is the file 1. So this is header file, and whatever the contents we have written in the file 2, that we can import in this file 1. And in text, see this x value we have declared it globally, and one of the function declaration, that is print function declaration, we have declared it, and inside the main function we have given x is equals to 10, and by using this printf statement we are printing that x value. And then next we have given the print function over here. We are calling this function, but we didn't write the function definition in this file. So the function definition was written in the file 2. So see here, this is a header file, and the extern we are using, external storage class we are using for this particular x variable. So that x value whatever we have given in the file 1 we can use in the file 2. And next, void print is my function so the print function definition I am defining over here in this file2, and by using this printf statement we are printing that x value which was given in the file1. So here this file1 program we are executing it. So see, so if you execute this file1 program, see, even though we don't have the file1 definition, file2 definition, which is nothing but print function definition in the file1, we can access the definition of that print function in the file2 by using this external storage class. So you can find here x in file1 is equals to 10 and x in file2 is equals to 10. So the file1 value x is 10, so that one we are directly printing here. And the next, what the definition that we have written in the file2, which is nothing but just we are using that x variable over here. So that x value is also printing in that file1 if we execute this file1 C program. So this is about external storage class. So we can use this x variable in multiple files if we are using this external storage class. But one thing we need to remind is that external storage class variable should be declared globally. So before the main function you need to declare it. And the scope and coming to the scope and lifetime of the program is throughout the program ends. When the program ends, the scope and lifetime, the availability of the variable we cannot use and the memory also will get erased. And next is the properties of all the storage classes. See here, this is the storage class. The storage classes are automatic storage class, external storage class, static storage class, and register storage class. And the keyword we are using for automatic storage class is auto, and the memory location for this is inside the RAM. And the next default value that we are using is the garbage value. And this coming to the scope and lifetime of the automatic storage classes, local to block in which the variables has defined, which means within that particular block, till the control remains within the block which variables is defined. And the next, coming to the external storage class, the keyword that we are using is extern keyword, and the memory location is the RAM, and the initial value, default value is 0, and it is global to the program, that is throughout the program ends that variable we can use. And as long as the program execution does not come to end, that variable will exist in the memory. And the next, coming to the static storage class, the keyword we are using is the static, and the next, the memory location for that static storage class is done inside the RAM. And the next, the default value is 0 for the static storage class and local to the block in which the variable has been defined. And the value of the persistence bit between different function calls initialization is done only once. The next register is the keyword that we are using for this register storage class is register, and the memory location is done in the CPU register, not inside the RAM. And the next, the value, default value that we are using for this register, if we not initialized, the default value is garbage value. And the next, local to the block in which variable has been defined, and coming to the lifetime, it remains within the block in which the variable is defined. So almost the automatic storage class and register storage class scope and lifetime and the default value is almost the same. Within the block, scope is within the block, and lifetime is also within the block. When we comes out from the block, the memory will get terminates. And the keyword is different for the automatic and register storage class. And next, coming to the external and static, the scope and lifetime, which means the variable we can use throughout the program ends. And it also exists in the memory whenever the program ends. And the keyword that we are using is static and external, and the memory allocation is done inside the RAM. Thank you.